6 p.m. Call the Riley Purgatory Bluff Creek Watershed District Board of Managers Workshop to order. Bonnie Nelson, I'm sitting in for President Dorothy Pedersen as the Vice Chair. We have 4 of the 5 managers here, so we have a quorum. Then our first item is Eden Prairie Low Salt Design Campus Retrofit with Lori Hawk. Welcome.
Vice President Nelson, manager. Talk came to us 6 months ago now, 4 months ago now.
Yeah, a couple.
Those some of you who've gone to the Water Resources Conference or other places, she has presented with Connie Fortin on low salt design, which is different than the low salt winter maintenance. She came to us a few months back, us 9 Mile Creek, Lower Minnesota, with this idea of since they're doing work on their campus anyway, of how to retrofit that campus so that it would smart salt design, low salt design.
Salt design, yeah.
We were all pretty excited about this idea. I thought that it would be best to have her present what it is they're proposing to the managers. It would be eligible under our cost share, and could pay for it through that, or if the managers would want to allocate it in a different way. But really tonight, it's just to get you up to speed on what it is they are proposing. And with that, I will turn it over to Ms. Hawk.
Great. Hi. Hello, managers. Hello, staff and visitors online. My name is Lori Hack. I'm the Water Resources Coordinator for the City of Eden Prairie. It's nice to be in front of you this evening, so thanks so much for your time. I'd like to talk to you about a really exciting project that we are going to be involved in here. It's called Eden Prairie's Low Salt City Center, and we actually received a $425,000 grant from the Pollution Control Agency. Yeah, around this. And so my purpose tonight is, like Terry said, just to give you a little bit of information on what low salt design is. And because it's, like Terry said, it's a little bit different than low salt winter maintenance, which we've been focused on for a long time. And then an example that you've actually seen already of a project that the city is doing. And then this next project, which is the grant funded project, for which we're hoping for some cooperation from at least 2 of the 3 watershed districts in town. And I can talk a little bit more about that later. So as you're aware, Eden Prairie has a lot of water resources. We have 18 lakes, 4 creeks, about 657 wetlands, 384 stormwater ponds, and the Minnesota River. So it's we are water rich in this part of the metro. So we definitely take our stewardship of those waters seriously. And as you know, chloride levels are rising. This is data from your watershed district in the Purgatory Creek chain of lakes, kind of showing the increases over time in chlorides. Most dramatically, those top dots on the far right side are Lake Idlewild, which is right off of Highway 5 and 494 behind Redstone there. So you can see there's a lot of impervious surface, a lot of chloride use in that subwatershed. So chloride levels tend to be real high in that area. But these trends are concerning because chloride cannot be removed easily from water. So it's expensive. I don't probably need to tell you, but it bears repeating that chlorides are definitely a problem. They're toxic to plants and animals. They can contaminate surface and groundwater. They impact soil health and soil chemistry and soil structure. They can affect the seasonal mixing of water bodies. So salt water is more dense than fresh water. It sinks to the bottom. And that's where all those really fun fish that we like to catch in Minnesota live. So that can be particularly problematic. And chlorides contribute to something that they're calling freshwater salinization syndrome, which is basically just all sorts of other problems related to increased chloride levels in water. So it has to do with heavy metals and things like that. Don't want to get too much in the weeds on the chemistry here, but chlorides are an issue. And there are a number of chloride impairments within the Twin Cities. In Eden Prairie, really the only impaired water body is 9 Mile Creek, so it's not in your watershed district yet, but I think they're probably coming, Josh, right? Yeah, we might be seeing some in the next couple of years. The threshold from the US EPA is 230 milligrams per liter. In Canada, it's about half that. So I think that's an interesting thing. They set the bar lower. So there's more exceedances potentially. This is an interesting graphic. I don't want to dwell too much on it, but basically shows the change in groundwater quality that we're seeing as a result of chloride pollution. In the upper left, you'll see a comparison of like the late 80s through the early aughts, and then from 2002 to 2012. And so you can see in the Twin Cities, there were some pretty large increases in chlorides. We've essentially in the Twin Cities slowed the rate of decline, which my retired friend from the city of Chanhassen, Jill Sinclair, and I used to joke about slowing the rate of decline all the time, because sometimes in natural resources, you don't feel like you're making good progress. You're just slowing the rate at which things get worse. So, but in this case, if we can do that, that's going to save us a lot of money and headache in the future, because as we all know, we need groundwater for drinking water in this area, and places like Madison, Wisconsin are already finding chlorides in their municipal water supplies. So this is not a problem that we can ignore for a whole lot longer. And in fact, we haven't been ignoring it. We're just not making as much progress as we'd hoped. The major sources of chlorides in our waters, that large puzzle piece is road salt. And on days like today, that's easy to imagine why that would be. We really like our roads clear from curb to curb. Water treatment plants is that big blue piece in the upper right-hand corner of the pie. Basically, that's all of the municipal uses for water. When you add chloride to your pasta, it ends up in a water treatment plant. It also includes salt from water softeners, which in Eden Prairie is not an issue. We soften citywide with lime. So there are very few salt-based water softeners in the city of Eden Prairie, but in other communities, if you're on a water softener, you're helping to contribute to that little slice of the pie. And fertilizer use is the other big piece in the bottom right part there. So there's a lot of disparate sources of chlorides, but there's a couple, 3 that are really big and kind of the major sources of salt. Eden Prairie, glad to say, has been leading in salt reduction. We have, as I mentioned, no or few, very few water softeners in town because of our citywide softening using lime. We have been doing smart salting training for about 2 decades for all of our plow drivers, all of our winter maintenance folks, even the folks who do parking lots and sidewalks. We have started, I don't actually remember exactly when this happened, but we started pre-wetting salt at the spreader. When you pre-wet salt, it decreases the amount you need to apply. And along with that, we started pre-treating roads with brine when we can. So if we know there's ice coming and it's appropriate to do so, we do pre-treat our roads. And that's where you see the little stripes running down the drive aisles. We also have 3 weather stations, one of which was funded by a chloride reduction grant from the Watershed District. Those are in different parts of the city, and they help us monitor in-time pavement conditions, which really helps our applicators determine how much they can dial back salt application. And we do have a snow plowing and ice removal policy that guides our decision-making on this. So we really have been able to reduce salt application in the winter. We have another thing that it didn't really dawn on me right away, but we do have some drain tile projects behind curbs where we're diverting run-on onto streets, sidewalks, and trails. So the tile projects go in behind the curb line, and then residents can run their sump pumps into those systems, and it keeps us from needing to apply salt in some areas where otherwise normally we would. So we've been doing the right things, and still we're seeing these increases over the last 20 years. And that's the piece where managers like yourselves and myself, we're looking at this and saying, okay, what else can we do? And recently, I became introduced to this low salt design principle. It really is spearheaded by Connie Fortin, who is the brainchild behind the smart salting trainings. But she came up with this new idea that is really brilliantly simple. Basically saying, can we put things on the ground that will later on require less salt? Can we design things and be intentional about how we put things together in a way that allows us to reduce our need for salt in the future? So that's what low salt design is at its core. Bolton and Mank has this low salt solutions brand that they've rolled out. And they've been doing a lot of work with pilot cities like Eden Prairie, Bloomington, Richfield, Hopkins. Now Edina just signed on, Rochester. They've been doing a lot of work on training folks about what low salt design is and what it means for places. So I want to give you just the briefest of run-throughs on low salt design. The things that we start seeing from low salt design are that we have safer winter pavements. That's the big selling point, is that sidewalks, pavements, parking lots, it all becomes safer when you apply these principles, and then we can reduce the need for salt. So as a public employee with a lot of different, cities have a lot of irons in the fire, right? We have our police, we have our fire, we have all of our streets maintenance folks. We really do need to put safety at the forefront. But the great thing is that this also reduces the need for salt. And then we get myriad other benefits as well. So again, I won't dwell on those because I want to get to this stuff. These are the 8 main considerations that low salt design incorporates when you're looking at a new site, either first-time development or redevelopment. So I would say the biggest ones in this are the bottom row, looking at where do you store snow once you've plowed it, using the sun, being intentional about vegetation, and outsmarting the wind. And we'll talk about most of these as we go through. So the first one is that vegetation impacts winter maintenance. I noticed it today in your parking lot. I parked on the south side of the lot here, and there are some nice big spruce trees on the south side on the property line, right? It's screening from to the neighborhood to the south, but what those do is they block the sun, which shines from the south onto the building. So the parking spot that I'm in is glare ice because the sun can't heat up the pavement. If we were able to be intentional, and we're not always, these principles are applied where they fit. It's not a forced fit. I think that's one of the brilliant things about it, is you try and use these things where you can. If we could replace those trees with some deciduous trees, then we could get more sun through those trees in the winter. If we can't, it's okay. We're not going to bat 1,000 on this. Even if we reduce what we need by half, that's a significant decrease over what we're building. So just being intentional about placing vegetation is the first one. And then with that, using the sun. On the left side of this graphic is a high salt condition. You've got the building on the south side. The sun icon is where the sun is on the south side. If you're thinking about this building, the door is on the north side. So your building is shading the front entrance, and that's where people are going to need to be. Now, could you rotate the building into the low salt condition on the right? Maybe. But maybe my friends in planning want to have a really nice corridor where they have the front of the buildings along the street or something like that. They have a very good reason for having the building where it is. So in conditions like this where we couldn't use the sun, are there other alternatives? Could we use a few square meters of heated pavement or heated concrete to fix or reduce further the need for salt? So just being intentional about using the sun, not shading it, putting entrances in places where they make sense. This is probably the one that will jump out at you today as you drive home, is horizontal drainage. So in this photo, you'll notice that on the far side are all the snow piles, and clearly toward us is the low spot. We know that because all the meltwater has gone from the grassy area that's probably surrounding the parking lot, melted onto the parking lot, is running down the middle of the drive aisle and cutting across to the catch basin, which happens to be located, you've noticed, in the handicap parking stall, right? This is probably the worst possible location for that catch basin. Could we do something a little bit different with grading, a little bit different with snow storage? If we move those snow piles to this end of the parking lot, the near end, then we could just have a catch basin right there, catch the runoff, and drain it away. Now,
They did kind of address it though by leaving snow in the handicap.
yeah, right, exactly. Yeah. And my uncle, who is an amputee, wouldn't really appreciate that very much. So, but the opportunity is to reduce that meltwater sprawl. Once we move snow, we don't want to have to deal with the snow or the water again, because the other thing that's happening is, you've probably noticed through your adult lifetimes, that the number of freeze-thaw cycles per winter is increasing. So we're getting more situations like this. We've had several already this year where we have snow melt running on and across surfaces. The same goes for vertical drainage. Can we move downspouts? Can we move some of our surface water management to places where it can flow and puddle without running into our parking lots? My townhouse has this situation. The downspouts from the large part of our roof runs right onto our front stoop for almost every building in the development. It's terrible design, but what can we do about it? And it's, again, we're kind of all laughing at this because we know we can do something about this. This is low-hanging fruit. That's why I'm pretty excited about this, if you can't tell already. On this one, it's just thinking about making things easier to plow. Again, my friends in planning love them, but they love these parking lot islands. They really impact the ability of plow drivers to get in and plow all the spots. So what folks end up doing in a pinch is they'll try and, like this morning, for example, maybe they just did a quick sweep through because they couldn't get all the stalls, and then they throw down some salt and go. And by this evening, it's probably fine, but they used more salt than they needed to. So can we design toward that low salt condition on the right side where it's easier to plow snow from every square foot of that parking lot? One of the things that was very cool about this whole program is that the city of Eden Prairie actually got training on low salt design. We had 4 2-hour sessions where we brought in, it was 17 different city employees from 5 of our 6 different departments and learned about low salt design. So we have a lot of folks in town who are and working for the city who know about these principles. And we've learned that, again, this isn't rocket science. We need to communicate between departments to see what we can do better. And we need to clean our house first. And that's why I'm here this evening. So one of the projects that you saw recently was the Eden Prairie Police Department remodel. Part of the city center at Eden Prairie is being restructured to accommodate our police department. And we had some opportunities to use low salt design in that design. I don't know if you noticed it, but in a couple places here where it says snow storage, on this aerial photo, you can actually see the meltwater draining from the snow piles where our contractor stores the snow in the winter across the parking lots. This is the existing condition, not the proposed condition. So what we decided to do, and remarkably, this took about 15 minutes in one meeting to get the redesign done, is we provided snow storage, we removed some parking, we were able to provide additional stormwater treatment and maintain an aesthetic that is suitable for our police department. So this is what the design looks like. We have an infiltration basin on the north side there. The police department entrance is over to the right. We have a fenced-in parking area for some of our larger vehicles. And we provided snow storage on both sides of that security fence. We also, right by just north and west of where that sun icon is, there's a flat area, well, flat-ish sloping area that's just going to be grass. It's actually going to be low-mow turf, and that's going to be snow storage for that parking lot. So it will be down in an area where there's a catch basin right there, so the meltwater can be delivered downstream without issue. It's also serving to increase green space near the front of the building. So what we thought.
I just want to remind the managers, this has already been implemented by the district, and this is going to be, actually, they started construction, haven't they?
They're close. Yeah, I think they're like receiving bids and finalizing plans and things. But yes, this is already done. So this was just an opportunity that we saw as staff, having been through the training. This will be the first low salt design actual built project, I think, that there has been. And the cost was minimal. Yeah, Tom.
So did you just catch this then mid-design?
We did. Yeah.
So it was already laid out?
Yep. And we happened to be working with Bolton and Menk, so they were able to have, it literally happened to work out that way. So they were able to kind of go back, have some internal conversations, but we kind of designed it for them. Like I said, it was literally me sitting in a meeting with some of my other colleagues who had been through the training. And we said, well, what about this? What about this? What about this? And we have more than enough parking, so it worked out great.
So-
Every site is not going to be this easy.
So on this particular picture, where was the snow pile before?
Yeah, so the snow pile, the big one was in the lower left corner where it says snow storage there.
Yeah.
And then there was another one that where the infiltration basin is going to be up in on the north side. Thanks, Terry. So down here, actually even further down. And then up here was the one existing snow pile is here. So this one's going to be the infiltration basin. And then this is that green space area that will just be low mow grass.
Sorry, what can we do to help?
Pardon?
I don't know how far you are into your presentation, but what can we do to help? What do you?
Here's where we are. So I'm so glad you asked, Jill. Thank you. So this is the rest of City Center. The area that we were looking at was just over here off your screen to the northwest. This main parking lot, you can again see the snow melt. I love these aerial photos that we get in the springtime because we can always see it. But you can see how the snow, we pile up the snow currently along the south side of the parking lot. And right now, if you went out there today, when I go there after I'm done here, we will see all of this going down to this one catch basin. Now, the dirty little secret is that there's a catch basin here, there's one here, and there's one here also. But the water is not getting to any of those catch basins. So we have meltwater that freezes on this entire drive aisle and all of these parking spots right now. So what we're hoping, well, what the grant application was for and what the Pollution Control Agency has provided us $425,000 to do. And I will say this is a preliminary design based on conversations with Bolton and Mank. And we just kind of did a draft. We don't have a full-blown design yet. But what we're going to do is extend some storm sewer in here, remove parking to provide snow storage here and here, extend storm here to catch some of the water that's running this way, and then provide, like I said, snow storage in a couple of different areas. We're going to remove the parking down here with the police department in the upper right side of the photo. Moving to the other side of the building, we will have less need for parking down in the east end of the building. So we're going to remove parking here and add a stormwater BMP. It'll be an infiltration basin again. We have great soils on site for that. And then we're going to add an inline stormwater structural BMP in the manhole there now. Right now, there's no treatment of this water before it goes into the DNR wetland to the north of City Center. So this is all brand new. Like, we wouldn't have to do it with a parking lot redo, but we want to do the right thing. So we're proposing to do this project, and we'll be doing this project. So with that, we were selected for the grant. It runs 2025 to 2028. The grant agreement has not gone to City Council yet. We're working on a draft right now. I have all of the information to the PCA, so they're drafting the grant agreement. It was, again, $425,000. We requested $500,000. The total project cost is about $740,000. Our match needs to be 25% of the award. So we're in it for at least $106,000. And that's where we sit right now. As Terry said, once we got word of the award, I reached out to the watershed districts because I wanted you to be able to be on the front end of this as well, because this will be the first project of its kind. The Pollution Control Agency typically awards money for education and things like rebates on water softeners with the chloride reduction grant. I think this is the very first actual capital improvement. So the district involvement, as I see it, could be a grant or other funding. I'm hoping that it will be like about $100,000, and that could be spread out over the entire duration of the grant. We've got kind of enough time that we could do that over multiple years, whatever works for you. And we're open to talking about that. Terry and I have a couple ideas, but we've got, definitely there's a need there and an opportunity. This is within your district also.
So that's actually a couple of really good points.
Yep.
So while the next things that she'll show, 9 Mile Creek can be involved in that, but public purposes, we can't spend outside of our district, and neither can 9 Mile spend outside of their district. So 9 Mile can't really put in any capital financial help on this project. They can help in other ways. The way our grant is structured right now, you can apply for grants in subsequent years. So while the grant agreement that's going to go before the board tonight, it's a $50,000 cap. If they phase that, and we paid for, we could work out what is phase one and phase two, but we could spread that that 100,000 over two $50,000 payments. We'd have to work out the details, but I think that's agreeable to them. It would work well with our funding the way we have it. That's kind of where we're leaning.
Put it into the budget.
And
So if
we-
you're moving snow into a pile.
Yep.
I'm assuming that's salt-free at that point.
That's the idea. Yes. And there will be a need for us to work with our contractor that we have do snow removal. You would think the city does its own, but we don't. We send our drivers out and we hire someone else to take care of our parking lots. So I've been working with our facilities manager up to this point on our contract and trying to get some things refined. They were already using the smart salting contract language.
Okay.
So those, the winter maintenance workers that we hire do have the training and things like that, but we would need to refine that as part of this. That's a pretty straightforward internal process to get them to clear before they salt, in order to preserve the vegetation really in those rain gardens. Because you're right, that's going to be absolutely important.
So when we do our salt plans, when we do permits, we have a salt component that's management of that.
Yes.
Can we incorporate some of these things into any of that or encourage them in any way?
So we could encourage them. So we've talked about a number of things. In fact, I actually met with Connie, Eleanor, and I met with Connie last week. Whether it be putting together design standards or something that they could choose from, but encourage them. We'll have to work with legal as to what we can actually require for. We might not be able to say you must build it like this, but it might be something where we say you can only have X amount of chloride running off a site, and then that would kind of compel them to look at how they're designing the site. So I think we can be creative in how we do it.
So who does that go through? PCA or who?
It just comes, it would be between us and that developer. So what we have right now is we require them to have a chloride management plan. And that chloride management plan is really nothing more than saying you must have the person who's responsible for administration of the plan and those who are applying or doing the winter maintenance must have gone through the PCA smart salt training or equivalent.
So to be clear, Jill, just to kind of give you an idea of where we are in this process, like these pilot cities just came on in the past year and a half or so. So we are all right now as municipalities trying to figure out exactly how we implement this. To date, no one that I'm aware of has rules. No city has a rule about, like Terry was talking about, X amount of chloride, or you must do all of these practices. What we're leaning towards as municipalities is having guidelines and providing the education and working with applicants on the front end, so that it's more of a carrot than a stick to try and to work through this, because some of the things are so very easy to implement. Moving trees is not usually all that difficult. So that's kind of how the municipalities are approaching it. There really aren't rules out there now that govern anything more than having a chloride management plan, having your salt stored inside, having trained applicators, things like that. So we're still kind of negotiating how that's going to come into practice. And we're looking at those things. Limiting the amount of meltwater that runs back on, for example, is one way that we've looked at having a number around it. But we're just not sure what that's going to look like for us yet.
With the spread and red calcs. The other thing is, so a lot of what the cities that you mentioned earlier, a lot of what they are doing is looking at their current design standards and code and saying, well, where does our design standards and code actually conflict with this? And that might be something we do. So,
parking lot islands, for example.
Right. Yeah. So for us, you can get abstraction through tree planting and preservation, and that's not something we're gonna want to give up. So maybe it's a matter of us looking at, okay, well, how do we apply that then? How do we, ask them to plant those trees? Do we say, there might be where we'd have the standard. So I think a lot of it really is, like you said, it's in its infancy to a large part. Just collaborating and figure out what are our barriers, what's standing in our way, and how can we move it?
I'm going to a meeting this next week, I guess. The DNR, it's a group of people that mostly the wildlife people, the environmentalists. But we're looking at what DNR is going to the legislature with for priorities, and they're saying, well, bring us what you think. I'm thinking a state standard on this or some kind of guidance might be helpful to back you guys. I mean, we hear it with shoreline stuff all the time.
Sure.
When we were just at the DNR roundtable, it's like, if we had some more state stuff in place to help us, we could do a better job. So I was just wondering.
Yeah, and Bolton and Mike is working on the stormwater manual. They got the contract for kind of revising that, and that is kind of sets the standard of practice for stormwater management. And so there will be low salt design included as part of that, which is exciting. And I don't know if anyone from your district is on that. There's like a small committee that's kind of working on how that looks in the stormwater manual. And I'm participating in that. So I think that is, it's a step in the right direction. Yeah, David.
So one of the things that strikes me, I have attended Salt Week stuff, and
Sure.
in a lot of places that I've lived, the parking ramps or parking garages are standard, and they have two advantages. One is you don't have to plow a covered parking area, right? So like at our airport, you only have to plow the top of the parking lot. Like, was there 9 levels? So 8 levels don't need any salt at all. The other part of it is you get a lot more parking, a lot more dense parking, so you can have more pervious area that can, absorb the water and recharge the aquifer, the groundwater. I'm sorry.
By going up, having more levels.
Yeah, by having more levels, you can take 1 acre worth of parking and turn it into 1/10 of an acre if it's 10 stories tall.
And I think that's a good example of that are some of the preliminary plans that have been floated for like Eden Prairie Mall, for example, their redevelopment. They are looking at, parking under or over other things. And I think that's an opportunity for that. As land values go up, that's going to become more and more reasonable. I don't know that we're there yet. There's a lot of places in town where, parking is an issue and it's expensive to go up. So, but it is, definitely something that can be
The other
part of the
thing that,
toolbox.
like in Arizona, they have parking areas that are covered with solar panels.
Yeah.
So, we'd have to have special whatever to get the snow off the solar panels, but we wouldn't have to salt. So that would give us 2 things, energy plus covered parking.
You're thinking like a low salt designer. That's, yeah.
You mentioned that you have design standards and you've learned those. Is that something that you're putting together like a brochure or checklist? So when you give out your permits at the city, that the developers get it early on when they're.
Yeah, so we're trying to navigate that right now. As I mentioned, there's a number of cities who are involved in the pilots. We're all kind of having those conversations. We're trying to leverage, all of us together because we're the first ones. We don't want to pay for it all, but we want it now. So there's kind of this dance between, do we want to be the ones to pay to develop it, or are we going to wait until something's available? Right now, Bolton and Meg just published the manual. Actually, you can download the low salt design manual on their website if you sign up. So you provide your email address, of course, and then they'll send you the link. But they also provided the pilot cities with checklists. And so we're currently working on kind of modifying those. We are more than that. We're having the conversations on the front end with the developers when they come in.
Seems
So
like a good way to start implementing this, like in the short term at least.
but we would love to one of the things that our group of pilot cities, because we do meet occasionally, has talked about is having watershed districts provide training for developers and their engineers about these things. I think the regional nature, like there's not enough development in Eden Prairie for me to design a training like that. But if we look at Eden Prairie and Chanhassen, Chaska, Minnetonka, we look at 9 Mile, Edina, Richfield, Bloomington, like there starts to be a benefit to the scale of that. So we're hoping to get some regional resources developed either through the stormwater manual or separately. We just haven't figured out exactly what that looks like yet. Getting, it's kind of like herding cats, getting cities to work
Or you're
together.
getting
So
towards the low salt design, and then I imagine, are you still doing things like just public perception about you don't have to have salt sitting around for it to be effective?
absolutely. Yes, that's a huge part. I have people on staff at the city who have said to me, well, you need to put down enough that it crunches. So I have, we all of us have work cut out for us with the people that we know. So yeah, we're still also doing that. The education hasn't gone away. We're just looking at this big capital project as a way to increase visibility and get people thinking about low salt design. We expect to have tours and things like that. And with that, one of the requirements of the grant is called a chloride reduction advisory group. So that will be representatives from, I'm thinking 1 to 2 per lake association in town, and at least 1 or 2 staff from each watershed district to meet. I think I have it scheduled right now bi-monthly is kind of what I'm thinking, throughout the grant duration to talk about this. Certainly your support of this project is great. The board, the CAC and staff support. I'm not sure what lies ahead of us as we try and get this done. So just knowing that I can count on you to help us be leaders in this is fantastic. And certainly staff has supported us to this point. Terry provided a letter of support for our grant application, which was fantastic. Oh, there you go. So any other questions you have? Yeah, Tom.
So it seems like there would be lots of opportunities for making. So this is focused primarily on new development and trying to figure out how to deal with anything new coming in to work it into the rules and things. It would seem like based on your example, there would be lots of opportunity to do a scan of the territories we all cover to look for low-hanging, easy modifications.
Yeah.
And so I don't know, that's where
Drones or something?
This parking lot.
This parking lot, yeah. And that's where we started, like I said earlier, once we got the training, my colleagues in engineering, in parks, in streets, in, fire and building, all started coming to me and saying, Lori, what about this? What about this? Can we do this? This is a problem spot where we dump a lot of salt, either by the bucket or by the truckload in a winter. And so, yeah, I think that's the direction. That's why we wanted to do this project, is to make it so that it's top of mind for folks, because I promise you, when you leave this meeting today and tomorrow, you will not be able to stop identifying areas that are problematic and looking for fixes. It's just so easy. Like I said, I did it in my front yard. So
I've listened to you give presentations before,
Yeah.
and I can't ever drive by a parking lot without looking at the snow piles, including today.
You're welcome. Yeah.
But anyway, I'm just wondering also if there's money always motivates. Is there any way to calculate a reduction in salt from this to throw that out to existing owners of buildings or maintenance people to say you'll save X, Y, or save this amount by doing this in addition to making a lot of people happy?
Yeah. So there is a significant, Minneapolis actually did a study that kind of got at this a little bit without knowing what they were doing. They were looking at sidewalk maintenance because, they require private property owners to do that. And they were looking at, do we, Terry knows, do we have someone do that? How do we manage that? Because sidewalks are not getting cleared and our residents need clear sidewalks for access and all sorts of reasons. But they found that, what was it? I think it was 50% of the calls for service were related to post-snow, like several days or weeks after snowfall, icing. right, non-related. So I went to our facilities manager. I told you that I'd been talking to him a lot. And I said, Rick, how often do you think that we have to call our company back out? And he said it's at least 30% of the time. I think it's a lot higher than that. But it's notable, the number of times that we need additional applications. So today, for example, is not the only time that we're going to deal with this stuff. Those snow piles are going to melt for the next, well, actually only like 3 days, right? Till this weekend when it gets to be 60 degrees. But we're going to have problems every time that it dips below freezing. So.
Is there any way to use brine instead of salt in some of the parking lots?
Yeah, it's
Does that
tricky.
still contribute chloride?
It does. It's less. And I've noticed that, where was I the other day? I was at the clinic in Chanhassen, and they use brine in their parking lot. But it's from what I understand from my applicators and street folks, it's a pretty narrow window where it will work. So
Gotta do it ahead of time.
yeah, and you need to have the crews on to do it ahead. So it's not always the best solution, but it is another arrow in that quiver of things that we can use.
'Cause it usually falls to Public Works to monitor the weather and know what's.
Yeah,
In Bloomington, where I am, it seems like they're always ahead, but
Yeah,
they've got to be somebody's got to be paying attention. So if they could notify
yes,
some of these other places.
yeah.
Yeah.
And this is a really interesting concept. So when the 101 was being redone, one of the things that we were actually pushing for to be put in were the weather stations that she's talking about, where it's because that hill going down, even with the radiuses reduced, it's still not a good hill to go down in the winter. But there was no motivation behind it. The movement wasn't there yet, and they're like, "Nah, we're not going to do that." Whereas I think
The other thing to add to that is like we have a new street superintendent. He has been looking at, I don't know if you've noticed them on bridges, like over the river in Minneapolis. There's one on 35E in St. Paul. There's areas with built-in, basically sprinkler systems. And I think it's Carver County has implemented these just using residential sprinkler systems and small tanks. They've been able to put in some brine application systems along roads that always have a problem. So we are being clever about it. The thing that I love about projects like this with this low salt design is this is a place that we haven't looked at reductions before. And I think if we can increase or decrease the amount of salt that's required in our built environment in the first place, that is the most promising thing that I've seen in a long time. So,
just like water resources in general.
yeah.
Thank you. That's Jeffy. I check on time. How much do we need for
Okay,
the
Joe,
next?
Joe's a fast talker. We've
Okay.
got.
Just want to say we can take more discussion. I just want to make
Well, I
sure
think if
that,
there are more questions, as long as we
Okay.
get Joe going by 6 PM, I think we'll be
okay, very
fine.
good. Just checking in if
would-
anyone has any other comment.
You'd think this would be something that the state would want to look at because there's concern about getting salt in our water. So I would think, yeah.
And I think that's why we got the funding. I honestly, when I submitted the application, I wasn't all that hopeful because capital projects had not really been funded like this before. But I think, like I said, I think we're the first one. So we got in kind of right at the right time when they were looking to pilot something like this and try something new and, look at getting reductions, through a retrofit.
Can you
Sure.
go back to the map of the chloride impairments of the state?
Absolutely.
Because one of the things, and I
let's
think
do
all
this.
the managers are aware of this, when we were putting that resolution forward, there was a lot of pushback on the chloride from outstate because they aren't seeing the issue like we are yet. So having the state do something, you have, it's everybody else is like, well, that's a Metro problem. Metro needs to deal with it. So having a statewide standard gets tricky in that respect, but
What about Met Council? Can they help?
yes, that would be.
Or regional?
Yeah.
It doesn't show it on this map, but Duluth, well, maybe that is Duluth.
That is, yeah.
Duluth
There it is.
bad.
Yeah.
They got a lot of hills
Yeah,
and a lot of
A lot
snow.
of hills, a
Yeah,
lot
they're
of shading.
short.
It's, everything is east facing.
Yes. Yeah.
This is great.
Poor soul design city.
Yeah.
But I would think we could certainly help with the educational.
So the working group, what's it called? The,
Chloride Reduction Advisory Group.
yeah.
Yep.
So I've already volunteered, Matt Nicolai and Andrew Hartman. They're on it, whether they know it yet or not. No, they know. So, I think it'll be a great opportunity. I really like your idea about a more regional training. Because if 9 Mile is a part of this and Lower Min is a part of this, the three of us come together, we could bring in Carver at WMO.
Would that be something that would be a grant proposal for sort of the next phase from this pilot is to develop a training program based on that?
Been doing training programs for a long time, just on salt stuff. But
Yeah, now
Yeah.
it'd be, yeah, to this.
And I think it dovetails nicely with what you've done already with the low salt, no salt MN grant that you got a few years back.
So I saw, what's his name? Geez, I'm spacing out. He's one guy from, I think his last name's Johnson, with League of Minnesota Cities. And so I was asking him about, it seems like we got grants from the state going in all these different places, because I'm on Bowser and I see. Said, but there's hardly anything going to the municipalities, and if we're trying to align things, some of these things they're designing or they're coming up with the ideas, I mean, they ought to fit with the municipal plans at the same time, so that we're cohesively approaching things. But he said because their cities are up in MS4s, that's a problem. So how is that a problem? I mean, would that be a problem here?
No, I mean, so like I said, we don't have any real impairments within your watershed for chlorides. So we're not being driven by our MS4 permit to do this. The current provisions of the MS4 permit are very minimal when it comes to this. Basically, we have to have an ordinance that prohibits outdoor storage of salt, that prohibits piling of snow, I think, on catch basins. And, there's a couple other things that we're required to have, but it's not a lot. This last permit, which is 2020 to 2025, is the first MS4 permit that's had any provision at all in the stormwater part, the general part of the permit for chlorides. So we expect there will be a new MS4 permit that's issued 2025, 2026, somewhere in there, that will go through 2030. And that one will probably have a little bit more. PCA is telling us that there is not going to be a whole lot new in there, but I wouldn't be surprised if they snuck in something additional about chloride just because of the increased profile over the last few years. And, part of Eden Prairie's reason, we want to be on the front end of this. We don't want to be caught behind, where all of our waters are impaired and we're having to catch up. And drinking water is the one that puts the fear in me, is because if we start having to desalinate groundwater for drinking, that's problematic. And if I start tasting it in my drinking water, that's going to be a problem.
Since we can't go to Idlewild to get it anymore.
Yeah, I guess not.
Thanks, Lori. This is
Yeah,
great.
thank you. Thanks so much for taking the time to learn about our project and to consider how you guys can step up with us in this, because I think it's, like I said, really important, very, cutting edge sort of work.
You don't need to have us do anything to encourage your city council.
I don't think so. I'll let you know.
All right.
Very, very. Are we connecting up with this?
What?
How are we connecting up with this? Or
You can host trainings and things.
One through the grant program.
Money.
So we're gonna help, the cost share program. We're gonna help fund it. We're gonna be part of their advisory group, and if we participate in trainings or other things, we're open to anything at this point. But right now, those are the three specific components. Feel free to stick around. This next part relates to you anyway.
Thank you, Lori.
Eat if you want. All right.
Terry, if you'd like to introduce our next
I
speaker,
would.
next item.
So managers, tonight I have personal information removal enabled. I don't care. We have Joe Bischoff, our engineering, is with us. He here, let me finish one thing at a time. Joe, I'm gonna give that to you. Okay, managers. There's a little bit of background I need to give you before I turn it over to Joe. Oh, you don't need to see that, but you can. So we have in our plan a number of lakes where in-lake phosphorus treatment, lake phosphorus reduction is actually specified. We have some lakes that are not. Round Lake is one of them. Lori came to us spring of last year because they wanted to do a treatment, an alum treatment on Round Lake. Recreational lake is very popular in the city. They've got the water park there. We are noticing some trends, and Joel will talk a little bit about what we're seeing. So in talking with legal about it, we were trying to figure out the best way to do it. And originally what we were thinking was that we would do the background, we'd do the coring, we'd do the dosing calculations, and then turn it over to Eden Prairie to do the work. But as we started thinking about it, it was, and then we would reimburse them for that work. There were two problems that came of that. One is just the inefficiency of doing that. We're already going to be doing alum treatment on the other lakes. We can go out for one single bid package. We can realize that savings. The second one was, again, the public purposes, and that because it isn't in our plan, the cost share, was talking to legal, they weren't thrilled about doing it through cost share. So what we are proposing instead is to do a plan amendment to include Round Lake in that. We will do Round Lake and Rice Marsh Lake together this year. We are a little bit putting the cart before the horse because we know we're ready to move forward on Rice Lake. That was a project that was already ordered. It's already in our plan. We were going to move forward with that this year anyway. But I want to get Joel working on that task order. And rather than doing two separate task orders, I'd like him to do the dosing and everything for both lakes at this time. So Joel will give the background, what we're doing. We will be on regular meeting tonight, asking you to call a public hearing on a plan amendment to add Round Lake to that project. Round Lake, when we scored it before, was a 24. It now is a 31 in our plan because we have a partner. We have a financial partner in this. So it rises to the level of any of our other projects that we're doing. So we're not trying to pigeonhole something in that doesn't fit with our priorities. We had a little discussion, and this one is still out there for another day, is an alum treatment a capital project? And you get different schools of thoughts depending on who you talk to, but we're not putting a structure in the ground that we need to go back and maintain. However, in our plan, we have specifically said we will treat alum treatments as a capital project. So for that reason, we need to do the plan amendment to do it in that way. If there's any questions about what I've just said, I'm happy to answer now. Otherwise, I will turn it over to Mr. Bischoff.
I don't see any questions.
Well, thanks for having me. Terry told me I had 45 minutes of a captive audience, so I broadened the scope of my talk a little bit.
All right.
But I wanted to look at that, we're watched. So I just want to talk a little bit about sediment, phosphorus, and activation in the district. This really is an investment that a lot of districts are going, a lot of managers are going, and there's a term for it now called geoengineering, which is basically, I call it better living through chemistry. Right? But we can manipulate the chemistry of these systems to our advantage. And we do this as alum treatments. So we've done it in the district for Rice Marsh Lake, for Lake Riley and Lotus Lake. But you're also looking at some other potential treatments, Round Lake, Lake Mitchell, Red Rock Lake, potential treatments in stormwater ponds. I've had some conversations with Eden Prairie staff. They're interested in using that to capture and maintain phosphorus in stormwater ponds. The Lake Susan spent lime treatment, that's a geoengineering project that you've embarked on to strip phosphorus out of stormwater. And then also looking at the Lake Susan wetland, we've had conversations in the past about what those sediment phosphorus recycling sources are, how that wetland functions, and some of those pieces. So it's really kind of a programmatic approach that you kind of talk about when we talk about managing eutrophication in the watershed. So I just thought, let's do some definitions. What's eutrophication? It's the process in which a water body becomes overly enriched with nutrients. We know that that leads to a serious threat to potable water, recreational overgrowth, all those types of things. But what's geoengineering? It's really activities intervening with the biogeochemical cycle to control eutrophication. So how can we intervene some of those cycles, whether it be sources or sinks in the watershed, to capture that phosphorus and manipulate it through some chemistry, changing that biogeochemical cycle. So while source controls are the best way to reduce phosphorus, we never want to stop that. It's very difficult in the watershed, and so many of our programmatic approaches are really developing sinks. When you think about a wetland restoration and we think about a stormwater pond, we're capturing phosphorus. We're not going to the source, we're capturing phosphorus and doing that part. So the things that are sources, better street sweeping, fertilizer management, some of those types of things. Those are the source pieces that you really need to stay on top of, but we can't get there in these built environments at this point. And so we're looking at some of these manipulations. So aluminum treatments in lakes is one of those. I'm not going to talk about all those because Terry didn't give me that much time. But you know, it's the process to permanently bind sediment phosphorus so it can't fuel algal growth. That's kind of the definition. So we're leaving it in place, but we're binding it to something that won't release it and allow algae to use it. That's usually a chemical precipitant of some kind. We use aluminum, calcium through lime. That's your spent lime kind of project. We use iron, lanthanum products are out there. You'll hear about all kinds of stuff that are out there now. There's zeolites and all this stuff. So people are really researching how we can use these different products, but those are the most common ones. So those precipitants bind phosphorus under typical environmental conditions. Some of those are sensitive to things like changes in redox. That's the reduction of sediments that's controlled by dissolved oxygen. Some things are controlled by pH, sometimes temperature, and then biological interactions. You know, we talk about curly leaf pumping phosphorus out of the sediments, or we talk about carp stirring up the sediments and mixing that up. So geoengineering is just an emerging science that we're trying to figure out, can we change the chemistry of these systems to our benefit to prevent eutrophication? I mean, that's the goal of what we're trying to do here.
And not do harm at the same time.
And not do harm at the same time. Absolutely. Yep. So we're embarking on, the district's been embarking on this process and thinking about, as a programmatic piece, how do we think about this and what does it make sense? We don't know the answers. Like people always ask me, how long does an alum treatment last? Well, it depends, and we don't really know. It's hard to measure that because I have to do an alum treatment and then measure it for 30 years and know if I get 30 years, right? It's hard to model those types of things. And so we're getting some of that. We're getting some data, and partially because of what Riley Perg is doing, we have some lakes that are 10 years old now in terms of treatments. So, you know, there's questions like, how do you define a successful project? What are the metrics for water quality, sediment chemistry, or biology? There's a lot of different people out there that say this treatment failed. Well, what does that mean when you say failed? By what metric are you measuring failure? Right? Is it still binding phosphorus the way you want in the sediment, but water quality is still poor? Is that a failed project? You know, these are the questions we have to kind of answer. And then how long should a project last? You know, when we think about watershed projects, we think about a life expectancy of a built environment. So like we talk about a 20 or 30-year life cycle cost. And when we do a 30-year life cycle cost, we have a rehab usually in there as far as maintenance or maintenance costs of those types of projects. So a stormwater pond in a 30-year life cycle may need to get cleaned out. So we include those costs. So I want you to think about some of these geoengineering projects in the same way. We're trying to figure out, can we make it for last 30 years? But if we have to do a treatment in between, is that really a failed project? Or is that just a maintenance of that project to do what you want. So it's just kind of a thought process in terms of how you think about these projects. And then what are the potential threats to effectiveness? Recreational uses such as wake boating. We've had conversations about Lotus, and we're going to talk about that a little bit. Would wake boating reduce the life of the alum treatment? I don't think we really know the answer to that. We have some thoughts on that, but answering those questions. Continued high watershed loading and burial. We know if we don't do something in the watershed to control that load, we can bury the effectiveness of an alum treatment and it won't last as long, right? So we have to think about that too. And then invasive plants and animals. Certainly carp can have a big impact on that. Curly pondweed, other plants, and some plants are beneficial. Native plants create peat, which is holds on to its phosphorus longer. It's harder to get the phosphorus out of that carbon complex. Whereas if you get it out of phytoplankton, that breaks down very quickly because it's a good, easy mineralized carbon source by bacteria. So we think about those. Yes, Tom.
What was high watershed loading again?
It's if you did an alum treatment and shut off the sediment control, but you have a lot coming in from the watershed, it'll continue to rain new phosphorus down on top of it. So then it'll be burial. So you have to balance that watershed load with the internal load to try to figure out how long is it going to last. I mean, all lakes retain phosphorus. It's a natural process, right? It's just a matter of, can we balance that retaining phosphorus, the recycling of that, and the watershed load? That's the holy grail of
We
lake
don't
management.
stop the external loading, it just keeps.
Right. That's right. And so you've already started on that path. I just want to remind you, you have a great adaptive lake management program where you kind of go through these questions of water quality. Is it internal loading issue or carp an issue? Is invasive aquatic vegetation an issue? Will the internal load last 15 years? So you've kind of set a benchmark of what you would like your internal loading to last, at least 15 years of that project, and then assess and monitor that program. So the way that we go about these geoengineering projects is we really focus on adaptive management, meaning that we set a plan, we collect sediment cores, we figure out what that plan is, we implement that, we come back and measure how effective it was, and we stay in this cycle until we get longer and longer effectiveness until we reach our goals. And this is just proof I do actually do field work once in a while. So that's our process, right? And we're trying to drive this high phosphorus in the superficial sediment down to low phosphorus and balance that with the watershed. So now it's all in equilibrium. So whatever's coming in, burial, and the release supports the water quality that we're focused on, right? That's our goal, is that equilibrium. So let's talk about, that's just kind of, I just want to give you some background on just kind of the thought process and how this kind of fits into your overall 10-year planning and planning process and management process in the watershed. So let's talk about some of these lakes and how we're implementing some of those. So if you remember Rice Marsh Lake, we had an initial dose of about 240 grams aluminum per meter squared. That was really high in terms of typical doses that were out there. So we said, let's spread them out because it's also a different source. It's not iron bound, it's labile organic. So without getting too much into the chemistry, it's a little bit different. So we said, let's apply 50 grams aluminum per meter squared. That should get us about 2 to 3 years of effectiveness. And then we can come back and reapply. And we would do this in 50 grams until we get up to 240 to see if that's what we need. The hope is we do 50 grams and maybe that lasts more than 2 to 3 years. And then we do it again and that'll last 8 years. And then we do it again, that lasts 16 as we work on the watershed and some of those other processes and as we reset the ecology of that system, okay? So we can adapt these time between applications in applying those pieces. So it's an adaptive approach.
So does that total dose number ever change, or is that a fixed constant for
Well,
you? I mean, do you revisit it if you've had a,
We could revisit it over time. I mean, that's looking at the sediment chemistry in a way that we think that'll be the maximum dose. That we don't think we would need more than that. Now that doesn't account for new burial and some of those types of things. And this really, in shallow lakes like this, you're looking for an ecological shift. What I want to see is more native plants, and I want to see more peat created as the sediments and less of that mucky sediment that you would expect with more phytoplankton. The idea is there, we've gone out and cored a bunch of lakes that are really peaty and the release rates are almost zero. You can't get the phosphorus to come out of them. Yet we go out to some lakes like this one, it was all organic material, but it was coming out, right? So what's the difference between those? It's the type of organic material they have probably. So how can we reset that? So as we do the alum treatments, get the plants we want, create the soil.
that was sort of feeling like over maybe your 15-year life cycle 20, if you get it stretched out, we might be able to revisit what's the maximum.
Exactly. Right. And we hope that that's not my hope is you don't have to apply that much.
Okay.
That's the goal here, right? We didn't want to go in and be like, well, let's apply that now, because that would just be a waste of dollars, right? Let's do this incrementally. So if we look at how it's working, this was the alum treatment in 2018, and this is where I say we're getting some data. Hypolimnetic phosphorus, there's not really a hypolimnion in Rice Marsh Lake because it's not stratified, right?
That's
But
very
bottom
valid.
phosphorus versus surface phosphorus all the way through last year looked really good. We were like, this is great. And so we thought it would go 2 years, which would be 2020, and it held for another couple years after that. And then finally in 2024, it looked like it broke through. 2024 year was a weird water year. Remember, we had a really wet spring and then it dried out in the fall. So we're not really sure how much came from Lake Susan because we're still working on that project, you know, that lake upstream and some of those pieces. But this says because there's hypolimnetic or this bottom phosphorus is increasing, it's getting close to 200 micrograms per liter, it's probably time to do the next alum treatment. Okay, but this is a success in my book because we got 5 years of effectiveness when we thought we'd only get 2 or 3. So that's great, right? Just to look at that, I think the alum treatment's still being pretty effective. So if you look at 2018, this is at the site in the middle of the lake. In 2016, the release rate was almost 5 milligrams per meter squared per day. We dropped it 85% in 2020. When we cored it again in 2022, it still was an 80% reduction. So we still had accomplished our goal of turning off that internal loading. So the question was, why was the water quality starting to change now? Is it breaking back through or what's going on there? If we look at some of the other sites, this is Station 6 in the alum treatment zone. It also, we didn't have a 2016 core, but it remained really low. But we sampled one site outside of the alum zone and it was almost 4 milligrams per meter squared per day. So that got us thinking maybe we didn't treat enough of the area of the lake and we should probably address that in this next application. So this is what that application looks like. The orange here is the original application zone. We've added this zone here, and that would get you an alum treatment will cost probably about $160,000. That was done in 2023. Our lovely administration is changing things with tariffs, so we don't really know what aluminum prices are going to be. So I put in a range here of $160,000 to $200,000, just kind of trying to adjust for what we think some volatility in the markets might be. But it's going to be in that ballpark to include this extra area. There's no magic to this extra area. That's really following just some contours. So if we needed to kind of go here to get the cost down and there, and that's part of our task order is to kind of work with the administrator budgets and what makes sense for science for the lake. But we do think you should expand that treatment out into this other area that goes in there. We are looking to buffer it. This is another place we can save money. If you control pH, sometimes we use sodium aluminate. That's basic. Alum is acidic, and we can balance those two together. We did it with just alum the first time, but we were bumping. I was nervous because we were kind of bumping at like 6.5, 6.6. You don't want it to go below 6. We use 6.5 as our kind of buffer number. So we can look at that again and talk to the contractor and just slow down the process because there's plenty of buffering capacity if we give it time to respond, and that could save us some money too. So we're going to have to look at cost between sodium aluminate, whether it's worth the extra cost and what we can get away with here. Kind of piece of that. So that's in task order 51 that Terry was talking about, plans and specs for Rice Marsh Lake and Round Lake, and I'll talk about Round Lake in a minute. That would be a fall treatment. So the contractors are getting really busy, but the good news is I heard from PLM and Lake Resto, both of them are interested in getting in the alum application business. So we haven't really been able to get competitive bids. So it's nice that there's some other groups out there that are talking about, we can do this too, what would it take, and going through that kind of
There goes our business idea.
That's gonna be my next job.
It's not a bad day when you're just out there driving the boat around and and then a post-treatment sediment analysis is already included in that, and that's part of our adaptive management, right? So we need to be monitoring sediment, so we can look at water quality, we can look at sediment. Is it sediment that's causing the water quality degradation? Did we not do enough in the watershed? What might that be? So again, this is how we define whether we've been effective with our project or not. Let's talk a little bit about Lotus Lake. Lotus Lake, if you remember, we had a 2017 UAA that said interload is about 68% of the phosphorus load. So we did a treatment in 2018 and we focused on the two deep areas that had the highest concentrations. So over in the eastern lobe and then the southern lobe. We did half the dose and we went back and measured. And we were pretty effective in those, but the water quality was still holding not as great as we wanted to be. I'll show you that in a minute. So we did a second treatment in fall of last year. If you remember, we went through the process last year. We did that second treatment. So now we're trying to answer the question. Oh, it's doing things on its own. Now we're trying to ask that question, kind of what's next in terms of that process. So these were the release rates, again, in milligrams per meter squared per day. We had almost 13, I think is somewhere around there for station 30. We dropped that below 2. Same thing as station 50. That's these two deep holes. It dropped down to less than that. So again, in terms of the release rates of what's coming out of the sediments, we were very effective at reducing that. But this is another example of, did we cover enough of the lake area to really affect the overall water quality? We may not have treated enough of the lake area to get to where we wanted to be. So we did measure, Josh went out and cored and station 40 here and did kind of a transect up the main part of the lake. And we found some higher release rates at station 10 and 40 and 20 was moderate. 20 is the one up here. I think that's 10, which goes here. 20 was kind of in the middle. And then 40 was right there. So in the next alum treatment we prescribed, we said, okay, let's expand that area a little bit. We were really targeting. So one of the concerns that was brought up at the time was, if you're doing alum treatment in some of the shallower areas, would wake boats disturb that alum? How would that affect its effectiveness? Okay, so a wake boat could disturb alum. It could stir it up in the water column. It will not fuel algal growth at that point. It will, the phosphorus will stay bound to that aluminum hydroxide and the algae cannot strip it off of that. So even if it resuspends, it's not going to fuel algal bloom. So I don't want you to think about this as a blanket necessarily. Once it binds that phosphorus, it's got it. It's not going to let go of it. Okay. But if it could, a boat traffic through here could make it move to deeper areas, exposing sediment below that, that could have some phosphorus that could cause recycling. So if you remember, we targeted greater than 15 feet, because that's what people were saying was probably safe from resuspension from this kind of boats that are out there. But we put a little buffer around the edge, right? We're not exact in our precision. So we did a little treatment around the edge to make sure that we really painted that part itself, and did the same thing up in the northern end. So this is where we're at with Lotus. So we did it this fall. We're going to have another season of monitoring. Josh is going to be out there figuring out water quality. But the question is, do you want to do something to try to answer this question about, do wake boats have an influence on the alum treatment? What could we do about that, right? So you could complete a study to determine the potential wake boat impacts. What we would do is we would do additional coring in each of these zones in the spring. We're already scheduled to do that, or this coming spring, we're scheduled to do that to get the baseline after the alum treatment. We would do additional coring in those areas, and I'd probably do 5 from each zone. These 2 would be our controls because they're deep enough that they shouldn't be impacted by wake boat traffic. And then these 2 zones would be our experimental zones, and we could just do an ANOVA, which is just a statistical comparison among these groups to see if phosphorus or aluminum bound phosphorus changes in each of these significantly. And so if we do see major change in the shallow area, but not in our control, there's a significant difference in that change, then that would say something's going on, probably wake boats that's resuspending and moving that aluminum outside of there. We'd also have the data to say, oh, aluminum concentrations went from X to Y. It went down in these zones, but stayed the same in these zones. There'd be some visual comparisons among that too. So we could do a study, something like that. That's up to the board on whether you would want to pursue a question like that as a part of that. We're also, there's some modeling and work going on in Maine. There's some alum treatments that are going on in Maine, and I'm connected with one of the researchers there through the North American Lake Management Society. And so we're working with them on some advisory boards. So we're getting a lot of information from the work that they're doing that can inform this process to go. So they kind of would work hand in hand.
Is Wisconsin doing some stuff too?
I don't know.
It's who?
Wisconsin?
Wisconsin. Thought there was something going on there.
There, I haven't seen any studies specifically that they're doing, but I do remember.
Looks like Chuck Bucker found something out
Yeah,
there.
I'll look at that again.
I know SAFL came out with their new report looking at their wake boat study, and they were looking at sediment resuspension.
It is out now.
It's out now is what I understand. So Mark Orger just told me, I have not read it. Mark was saying that he thinks they're recommending 20 feet of depth for boat operation. And so that would kind of change, this is the 15-foot contours on the outer edge of this yellow blob that would narrow and then take away some of this area from boat traffic, or at least say that's susceptible to resuspension, but we don't know that for sure.
Is that
Yeah.
study, we contributed 10,000 toward something originally. Did we end up contributing any more? Sample stuff?
We reached out to them and did offer to contribute more to the second one. They never came back and asked for that funding, so I assume they found adequate funding.
Okay. Because I was saying it'd be nice to do stuff in house, but I'd like to hear your perspective on that too. I mean, what you think. I mean, these questions are asked, so. It'd be nice to bring it in-house if we can, with Joe's help to.
Yeah, Josh would do all the coring the way we would set this up, because you guys do all your own sediment district. I would just be on for data analysis, statistical analysis, and some of those pieces.
But it'd be cheaper to do it in-house, right? If you have the time and capacity. With Joe's help. Okay. Well, your input's always important, Josh.
Manager Deval would like to.
So you're talking about the aluminum binds with the phosphorus, and that's a permanent bond.
Correct.
So what were we talking about again? Is it the wake boats that are churning up phosphorus that's not bonded, that's been below the sediment layer?
Yeah, so if you think about it, your sediment profile looks like this, and we put alum, it rains down on top, and it incorporates, say, the top 5 centimeters.
It forms a layer. I mean, it's like
Right.
it's like a blanket on it. I
Well,
think you said that.
no, but careful to go there, because it's not a blanket.
We
It's-
lay it on like a blanket, but once it binds that phosphorus, it doesn't matter where that phosphorus goes, it's not going to let it go.
Okay.
So if you have resuspension, it goes up in the water column, it's still not going to grow algae, it can settle back down, right? And so it can do that process all day and it won't drive algal blooms. If it goes up and moves to the deeper part of the lake and keeps moving down the lake, you can expose deeper sediments. So it's kind of a blanket in that standpoint, but it's not a blanket in that it's capturing, people think about any phosphorus that's coming up through the sediment, it's capturing all that.
You could get scouring, let's say.
You could get scouring, exactly. And so if you move that out, then that deeper sediment might have phosphorus that's releasable in it. And then that's exposed now and close enough to the water to release.
Same as brand new phosphorus entering in
Correct.
Yes.
when that's exposed.
Yep.
Exposed, yeah.
And we call that burial. So that's coming in and burying your alum treatment.
And the wake boat study is to determine the impact of wake boating period on that churn.
So the question would be, is if we put alum in these 2 shallow areas where wake boats operate, does it move the alum away from those zones because there's resuspension as a result of wake boat? It's probably not wind resuspension because the prevailing wind goes like this, so there's no fetch in there. So there's not a lot of wind energy that could resuspend it because you're kind of perpendicular to that prevailing wind. If it moved, it's probably a result of that wake boat activity.
Do you have access to any of the preliminary information from the University of Minnesota wake boat study on prop wash to get a better sense of that depth that?
I do, and that's where I said it. 15 feet is what the stuff. This is all new, right?
Correct.
15 feet is what's kind of been the rule of thumb out there from a number of studies in Canada and other places. We just got the report. I have not even seen it yet. A colleague of mine got it at BAR, so I don't know. But he told me 20 feet is what they're recommending. So they're recommending wake boats operate 500 feet from shore and in greater than 20 feet of water.
I like this, if this helps inform the body of evidence about wake boats, this report seems like good timing with the report from the University of Minnesota coming out. I also, hopefully, if you do this, would talk to somebody about where the wake boats tend to go on Lotus Lake, like that East Bay, I would think might inherently be a better control than anything on the main channel, just because of the volume of, but just to take that, maybe have a different way of how you get your controls based on how the lake is used too.
Agreed. I agree 100%.
Okay.
And so we have in here the district or the association or somebody help us survey or record boating activity. So somebody would have to go out from the district and say, what's the general path that these boats go? What's the number of boats? I mean, you're not gonna be able to do it.
No, I was actually, I'm out there almost every day in the
Okay.
summer. I could be on my paddle boat. You could just give me a clipboard.
Okay, perfect,
Just
right?
volunteered.
I mean, but we could get lots of input from
Yeah.
people I know who live there, people who, you
That
know,
would be
on
great.
different,
Yeah.
we could look for.
And this is still, in my mind, this would still be a control. There's two deep holes here. If they go up, if they increase in aluminum, that means there's a new aluminum source bringing it in, right? So that would tell me it's resuspending here and making its way to the deeper parts. So that ANOVA can tell us direction too. Is it going up or down? You know, is it statistically different and statistically increase or statistical decrease would be the piece. So if this one was going up, this one stayed the same and these two went down, that tells us the aluminum's moving around, right? And then we tie that to the boat traffic. Again, we're not going to be able to tie it directly. That would be an expensive project to try to measure prop wash or energy or those types of things. But this would give us some idea of if we're doing alum treatments in these shallower areas, is that going to be effective in the long term? Or is wake boating or potential boating in general going to reduce the effectiveness over time?
And just one other thought as you're talking about this, that I've personally noticed every year the boats are getting bigger. We just last year got more bigger boats, bigger than what they're using during the studies to determine this information. So maybe that's another component. We could say that we're making this decision, assuming that the boats are even smaller than what we're seeing on the lake,
Could,
potentially.
But some of the studies actually showed that the size of the boat was less important than the displacement and speed that it was going. So if you take a smaller
Or the
boat,
design or
go
which boat it
slower.
was. Right.
Yeah.
It's not just the length. I
Yeah.
appreciate it, but it's.
Well, we might as well look at that.
I think.
Well, it'd be nice to know, have a survey of what boats are
We could
operating.
take
on
it-
those.
Just what.
Right.
Boat manufacturers are advertising a higher wake. A higher
Right.
wake
More
is
displacement.
more displacement. Do you go to the boat show, Fred?
What's that?
Do you go to the boat show here?
I've not been to the boat show. I probably wouldn't be popular there.
To see. To see
That's
what's
what I'm
up.
saying is I don't know that size will be a good proxy because prop angle, what the
Mhm.
wings that they put on it, they do a number of changes to the
True.
boat to just
True.
force
But if
it.
you wanted to kayak around and all the boats sitting on their lifts and just write down who's the manufacturer, like some
I think
basic
that'd be
information like
great.
Yeah,
that.
that would
Think
be
it could-
Or survey the
More
lake
information.
or survey the lake association to find out what boats are operating or what boats people own. Then we can look up that manufacturer information about displacement versus size, all those things.
Kind of validation.
Right, yeah, and this is something we can reach out to SAFL too, just to say, hey, we're thinking about doing this, if they have any interest in being a part of it, or if they have funding, looking for stuff like that. We certainly could do that.
That want to go kayak all the time.
Right. The problem is we are a little bit under the gun because we want to get the coring, if we want to do it, we want to get it before boating season starts. So we would need Josh to get out there before, we need to get this designed, the actual design, and we want to get out there before, probably end of May.
You'll be out there doing curly leaf pond stuff anyway. How does this affect the fisheries then? The food system within the water column?
Yeah, so,
Are there trade-offs here? Go ahead.
yeah, so you're talking specific impacts. You're gonna have more fiction, again, if that's invasive or native, that can impact. If you have a- Smaller fish. He's feeding on. All kind of tied together, the lake.
Please turn on your mic.
Keep an eye on it.
Yeah, so
You know,
we are doing, a bench sampling and very consistently. Some of our lakes we have. Are tracking some of it. That's along with the DNR doing their standard.
Okay.
On some of our areas.
Just seems like that's got to be a valuable database with all the stuff you're looking at. So the long term.
So that's just for consideration. We can develop a task order for that, for your consideration, and have that at the April board meeting. Is that right, Terry?
Yep.
Have it for that, if that's something that the board would want to see and want us to kind of pull together what that would look like.
It makes sense.
We could ask them up on the agenda.
Okay, so now out onto Round Lake. We just missed Lori. The city's been managing Round Lake and doing alum treatments on it since as far back as 2012. PLM's been doing those applications. So when PLM first started, they were just tracking their boat. And so you see all these lines are alum runs and they were just kind of spreading it out. In 2018, they did it again and they gave us this blob, but it's pretty clear they didn't apply all the way out here because you can't apply in that plant stuff. So it's not really sure exactly where it went, kind of stuff. But we have what those are. They did 7,800 gallons over 28 acres. That comes out to about 15 grams aluminum per meter squared. And over here, they did that again at 15 grams aluminum squared. The dosing at this time was really done by water column, what the water column could accept without buffering. So they weren't really thinking about the sediment chemistry. They didn't have any sediment chemistry to do that, but they were just using this as a tool to improve water quality.
Why is the SM flashing?
Question?
One, that mean they have their hand up or something?
Yeah, she was just pointing out that the online guests were unable to hear Josh.
Oh,
Okay.
red.
On purpose.
Okay. There's a hand up. still.
Sharon's got.
Hi, can you hear me?
Yep.
Sorry. I think Josh, when you were talking, we couldn't hear you. You were if you were talking before Jill and you're sitting on this side of the room, I can't see you, but I think if you were talking, we couldn't hear you at all.
Yep, we figured it out. He didn't press his mic.
Oh, okay. Thank you. Thank you.
Thank you,
Appreciate it.
Sharon.
So looking at water quality for Round Lake, total phosphorus is really in pretty good shape. Coming up into 2023, it's kind of trending down. So they're doing well in terms, these are the two alum treatments, and then water quality has improved since they've started doing those alum treatments. Chlorophyll A is holding below the state water quality standard, and Secchi depth is actually holding below that. So from a water quality standpoint, I think there's some benefit in these two treatments. You can see it was up and down before that. And since they've started those treatments, they've trended down in that part. If we look at the bottom phosphorus or the hypolimnetic phosphorus, you can see back at 2008 how high it got, over 1 milligram per liter. I mean, that's pretty hot, right? And then after they started doing alum treatments, the first one in 2013, you can see it drop here in this area, or let's see, they did in 2013, it dropped a little bit. Then it started to come back up high again, did another one in 2018. That lasted for 3 years, and then it's starting to recover. It did get up over 400 micrograms per liter. That's pretty high for hypolimnetic phosphorus. The threshold that I use, and this is just my experience, I don't have data to prove this, is 200 micrograms per liter. If it's under 200 micrograms per liter in the hypolimnion, usually we don't see water quality impacts in that lake. Once you start creeping over 200 and reaching 400, 500, you start to see the water quality go down. And I think that's the threshold at which you get enough diffusion up over the thermocline to start driving algal blooms. Kind of piece. So it's going, although water quality is doing well, it's going over 400 micrograms per liter and definitely trending, increasing in hypolimnetic phosphorus. So there's a potential that this downward trend could start to go back up in terms of water quality and doing that. So that was kind of the reason behind the district said, okay, well, we haven't done it. Eden Prairie's doing this based off of the water quality component. We haven't done any sediment chemistry. I think did the city approach you and say, hey, could you guys do some sediment coring?
Yep.
We'd like to look at the sediments themselves to see what is going on in there. So we went out and we took measurements of release rates. It's 1.4 milligrams per meter squared per day. That's not super high. Usually when I do an alum treatment program, it gets below 2 is pretty good, and holding below 2. But again, we have this other piece, which is important, of 400 micrograms per liter. So it's high enough that it's driving pretty good concentration, and that could just be the size of that hypolimnion versus the sediment area that matters in terms of the mass flux and those concentrations. So it seems to be enough to be driving some water quality issues, and we do see a really big peak of iron-bound phosphorus looking at the sediments. Iron-bound is the most releasable form, so when it goes anoxic, that's the first thing that starts coming out of the sediments. And so alum is really effective, and you can see it in the top 4 centimeters. It's really effective at stripping off that iron and putting it onto aluminum. So here's our aluminum fraction, and you can see down to 10 centimeters how we have this peak of aluminum bound phosphorus in the superficial sediments, and we have this reduction in iron bound phosphorus. So the concern here is this peak here, as this starts to migrate up through that, is it starting to break through that alum layer as it loses binding efficiency or gets saturated and starting to move up in there. 15 grams per meter squared is a very light dose. I usually don't do anything under 25, and we typically operate closer to 50 grams per meter squared. So those were the findings that we presented to the city that wants to pursue the project. We said, you know, water quality is holding, suggesting there's no hurry for an alum treatment. This was last year. And so we thought if we're going to do an alum treatment, it makes sense to put it together with Rice Marsh Lake because we want to buffer that alum treatment. If you do a really small buffered project and they deliver a partial truckload, they charge you a lot of money for that. So if we can combine it with another buffered project, then the cost goes down. There's just efficiency associated with that. The sediment, the TP was trending down, but the sediment P release was, you know, relatively low. But hypomagnetic P was increasing and exceeded 400 micrograms per liter. So it's a little bit of a convoluted story, but I do think that internal loading is affecting or potentially going to affect water quality because of that higher redox P. We calculated a longer term dose of 100 grams per meter squared, right? And they're putting down 15. It would take you, what, 8 years to get to your 100 at 15. So we thought increase the dose to improve longevity, somewhere between 25 and 50 grams aluminum per meter squared. Part of that would be city budgets to say, you know, where in that zone do they have money to pay for that? Or is the district paying for that now, or
They,
no, the
we
city?
will be paying the upfront cost and they will be reimbursing the district for the
Right.
costs.
So part of that's conversations with the budget that they have, really doing a better buffered treatment and doing that in conjunction with Rice Marsh Lake. And so that's been included in task order 51. So in that task order that you'll see tonight, it's going to be plans and specs for Rice Marsh Lake and Round Lake. Because we do the plans and specs document doesn't mean you have to do the project when the time comes. But we wanted to just get that, as we're doing this all together, there's efficiency to just get those plans and specs all put together, and then we can adjust from there as we go.
Would there be more external loading around Round Lake?
A pretty small watershed.
It's a really small watershed. So we have been working with Eden Prairie High School and putting in a water capture and use on it, which that's probably the largest portion of the watershed aside from Round Lake Park itself going to it. So so we are identifying some in the watershed BMPs that can
Okay.
be
I
implemented.
mean, it's something we should be aware of, right?
So is part of this what you would consider almost like doing a maintenance dose of alum versus a improvement to try and keep the water quality from getting bad, instead of us being reactive to kind of what can we do to keep the water quality at the level it's at?
I think that's a fair assessment of where the project is because the story is kind of convoluted.
Well, that's where it's sounding
Right.
like to me.
Right. And that's what the city wants to do. That's how they've been doing it. They've just been doing it from a water column dose. How much alum can I put in and still keep my pH above 6.5? Right. And that comes out to about 15 grams aluminum per meter squared based on the sediment chemistry of that peak. So now if I'm dosing for the top 10 centimeters, because I know I want to capture this peak onto aluminum, that's the 100 grams per meter squared gets us
Right.
there over the long term. I think it still makes sense to do it periodically, right? Because if I put it on top, it's not necessarily going to drive itself down that deep. We're going to put it on top, it'll diffuse up, and we should see this peak go higher and higher, more and more aluminum bound and less.
I like this. I hope that it could inform maybe what our management of this in lakes that we've done alum treatments, like into the future, maybe if we do get water quality or meet standards, maybe like on Riley or
Yep.
hopefully Lotus someday, that this might be something we do instead of, yeah.
That's the idea. Yep,
Okay.
absolutely.
Moving upstream,
Yeah.
so to speak.
So Mr. Bischoff talked earlier briefly about buffering and does everybody understand why it matters the pH level when we dose for alum?
Could you
Would you
explain
like
it?
him to explain that a little bit? I would.
Well, yeah, I mean, pH, so alum changes species at different pHs. So when you go below 6, it changes from aluminum hydroxide, which is what we call an insoluble form, forming that white flock, and it solubilizes, and then that can affect fish and macroinvertebrates. It starts to stick on the gills. Same thing happens above 9, 9.5 of a pH. So we want that pH to stay in that range. So when we do an application, aluminum sulfate is acidic, it's going to drive the pH down. And so we can buffer that. Sometimes the lake can buffer it itself. So we can put it in and the pH will stay the same. Sometimes we need to add a buffer. To add a buffer, we just use a buffer with aluminum in it, sodium aluminate, and that controls the pH at that time. Once it's in the lake, that pH, that's a typical range anyways. Like we wouldn't typically see it outside of that range.
Is this for all lakes or Round Lake, because it has so many people in it? Does that have different component of what you're measuring for?
It's not really the people, it's geologic. So we work on lakes in Iowa, but they're higher on the pH scale because they have so much limestone bedrock is their geology. And so the alkalinity of those lakes just tend to be really high. We're less well buffered in the Twin Cities and in Minnesota, so then we have to deal with some of this buffering. It really depends on the lake and how much I want to put in and that alkalinity in the lake.
Like Lotus, we didn't need to buffer.
We didn't.
But I guess my question more was because it's such a small body of water and a large quantity of people in it, is there a different standard for the fact that there's a lot of people
You mean the water quality?
in the water quality in terms of the,
So are you asking if the water quality worse because of all the people that use the lake? Or
no, if, does it change the mechanics of what we can do with the lake or?
So they're going to have a human health effect is what you're asking.
Yes, that's what I'm
Yeah,
asking.
no, it's safe to use. They use it in drinking water all the time in the drinking water plant. It's the same component that's in Malox. So if you take one dose of Malox, right, you get more aluminum exposure out of that one dose than you would out of swimming in Round Lake. We're putting it all in deeper areas, so you're not really exposed to the aluminum to begin with.
Okay.
Even if you did get exposed to it, you would have to ingest, I think, what did I say? A whole tablespoon of sediment every day for like 10 days to get to exceed the World Health Organization's standard rate for that.
Don't eat the sediment.
Yeah,
Yeah.
don't, just don't.
Aluminum's in all the food. Like there's aluminum in soil. So when you eat corn, when you eat broccoli, those all have aluminum in it already because they take it up from the sediment or from the soils.
From the soil, yeah.
So it's very safe. That's why we like aluminum. There's other products out there. I mentioned lanthanum, but lanthanum showing to bioaccumulate, and we don't really know what that means. So if it bioaccumulates, it may not affect the fish tissue, but will the fish not be edible at some point? Because lanthanum can be very toxic to you. So while there's lakes getting treated with lanthanum right now, we're reluctant to go there. I'm personally reluctant to go there until I really understand bioaccumulation and how lanthanum acts in the environment. The beauty of aluminum is it's naturally in all lake sediments anyways. It's the third most abundant element in the Earth's crust. So you have so much aluminum already building up in your sediments. So we're just adding a little bit more. Now, could we add too much? Probably. And we're always talking about those. But I've had a lot of conversations with the sediment toxicity experts at the PCA about what's too much and should we consider it. And when they look at toxic sediments, they don't even use aluminum as part of their calculations because it's not considered at all toxic.
So as we go forward with the holistic lake management, trying to look at everything, plants and fish. So we're looking at the trade-offs for the fish as part of that holistic approach. With
There's
lake
really
management.
no trade-off. We're clearing up the water. We're resetting the ecological system. So we're increasing plant growth. So in Lake Riley, we saw an explosion of native plants.
Okay.
That's good for macroinvertebrates and fish. So really,
Okay, so it's
there's
a
no-
macroinvertebrates, okay.
yeah. So there's really no,
Okay.
it's only
So
during the
they're feeding on the
application.
vegetation.
Yeah, there's only during the application process you have to worry about pH. And then after that, you've reset the system. So when you do an alum treatment, you are stripping all the zooplankton out. I mean, you're basically resetting the system. Those recover within a few weeks to months, right? And what you get after that initial shock of the system is a much better ecological condition that is better for fish and macroinvertebrates.
So we're tracking all that? You are, I mean.
How are we doing on time? I got one more to get through.
Yeah,
Microphone.
let's wrap it up, in maybe 6 minutes.
Anything else on that? Okay, just moving on. The last one is Lake Riley. So Lake
Before
Riley.
we leave Round Lake, this is Lewis, Madam
Oh.
Chair.
Yep.
Yes.
Just a question, maybe it's for Terry, but in terms of our plan amendment and how the plan has historically looked at Round Lake, and it seems like it's previously been a city-managed resource, is there a change that we're foreseeing in terms of the district's responsibility for the resource? Or is this a project opportunity, or how would we characterize our historic attention with Round Lake and where we are now?
So this is an opportunity to do a project at this time. I don't see it changing our long-term management of Round Lake. However, as we go into the next iteration of our plan, we will talk about Round Lake specifically. We'll talk about all of our lakes and the whole lake management plan and what it means to us. So I think the question is a little gray at this point, but will be addressed before we would need to do another application anyway, because we'll have a new plan iteration in which we will address Round Lake specifically.
Concerning this later, but it relates.
Does that address your question, Mr. Smith?
Thank you.
That's informing that.
Okay. One last one to go through, Lake Riley. This is our poster child for success. I hold this one up all the time and see it works, and it can work great. So Lake Riley, remember we had these 2 different zones of application, and we have 4 monitoring stations, 1, 2, 3, 4, where we're tracking our effectiveness over time. So we did those treatments, second dose in 2020. This is the beauty of having the sediment chemistry, is we can actually track change and understand, are we accomplishing what we set out to do? This is aluminum bound phosphorus. So that's what we want, is we want that phosphorus to go on to our aluminum. After the first treatment, we saw a jump to go there. Then we measured it again in 2020 just to see how things were doing. It continued to convert phosphorus over 2016 through 2020. So 4 years, it's constantly grabbing more and more phosphorus, but it's slowing down the pace because we're losing binding sites. Alum crystallizes and losing some. So we did the second alum treatment in 2020, and we saw another big jump in aluminum bound phosphorus. And even bigger than, so when you look at, I don't know if I have it animated in here, I don't. But when you look at just the change of this period here to the change here, it was even greater. I think what happened was, what's
Is
that?
it cumulative, this graph?
Yes, it's cumulative.
Okay.
Yep. Yep. And so the change from this point to this point was greater than the change from this point, and the rate of change was much greater. Part of that's, I think, the first alum treatment tends to take up all the binding sites from like dissolved organic carbon and all the things that scavenge the binding sites we want for phosphorus. I think the first alum treatment is kind of plagued by that. And then when you do the second one, you've taken up all those other sites, and the phosphorus is the only thing left to bind onto that. This is why we split these doses and try to do this over time, is to increase that binding efficiency. So the more efficient we are, the better money spent that we have. So we saw great conversion over this period. We saw aluminum bound phosphorus. This is station 1, 2, 3 was in a lighter dose. It didn't have as great a change. So you can see it was a pretty small change after the first treatment, and then it jumped again when we did that second treatment. I think that's additional binding efficiency in those sites. So that was a real success. We were really happy that we saw that kind of binding efficiency. And then we saw what we wanted, which was the release rates going down. It went from almost 7.5 milligrams per square per day, 83% reduction by the time we were done with that project. That's what we want. We want to reduce that phosphorus 80 to 90%. And that was at all stations. We had really low. So see here, we're under 2. That's a pretty good benchmark for when we do these alum treatments. They're all going to still continue to release, but if we're under 2, we're pretty successful typically in maintaining water quality. If you look at phosphorus, it did exactly what we want. This is surface water phosphorus. You can see it dropped after the first treatment, and then it started to bounce up a little bit in a couple of places. And then after that second treatment, it just kind of bottomed out, and it's been holding really well since then. Same thing with hypomimetic phosphorus. We had, before the alum treatment, concentrations of almost 1 milligram per liter. It came down significantly at the first treatment. You start to see that kind of breakthrough a little bit. We did the second treatment, and it dropped it, and it's been holding much better. However, Josh made me sad this year. Not really, but we see this little increase starting to come back up in 2024. So there is some question about whether this is changing, whether this is starting to come back up in terms of a release rate. or whether that's just some kind of anomaly or something along those lines. So talking to Josh, we thought coring it this year would make some sense. Maybe this fall, go out and get sediment cores. We can add another bar to these graphs to see where we're at now in 2025. What's interesting is the city of Eagan recores all of their lakes and water bodies every 5 years. There was no real basis for that other than that just felt like the right spot. When we look at data like this, it's like a 5-year program for monitoring sediments is starting to make some sense, right? We just get back out there and measure some of those changes.
Is this where you were looking at the 3-year cycle before? You were talking about 3 years and then seeing if it modifies over time? Is that what this is showing here?
Correct.
So the last graph on the bottom is showing that there's some accumulative effect of whatever we're doing.
The cumulative effect is here. This is the conversion. We're binding up that phosphorus onto the aluminum.
But on the other chart, the line graph, that one is showing that 3-year versus longer cycle time. It's demonstrating that you don't necessarily have to keep doing it 3 years.
You're correct.
Every 3 years.
Correct.
Is this being researched much in the country or in our region?
You're doing the research.
We are.
Really, I mean, there are a few, I work with, so I teach the BOM Workshop at North American Lake Management Society. So I have a couple colleagues that help me teach that workshop, but that really is the core of the researchers. There's a few others, Harvey Harper in Florida and some others. So we're connected with all of those, but there's only a handful of people really looking at this kind of
Yeah,
research.
how do you think I get published? I just sign on to what you do.
Terry is first author.
And
No.
Josh gets a footnote.
Yeah,
He goes in the
He does all the work.
So that's the idea here is like here we did the first treatment, it started to come back up. Now we've pressed that longer. I was hoping that this would stay low and 200, we're not over 200 yet. If this stays low for 10 years, that's a really successful project. And then we get that longevity, but it's hard to predict how long that's really going to last.
So we really need that core.
So the coring just helps us understand this blip and what's happening in terms of the chemistry. Maybe what's going on is we've converted and then we flattened out. We have no more binding sites left for a new phosphorus that gets rained down or that migrates lower in the core, and maybe the refresh of these sites might be. And then what would that dose be? And what is that from a maintenance dose? So this gets down to a conversation Terry and I have been having a lot lately is this project maintenance. Is what makes sense? Are future treatments required? At what interval would it be? And does that program, that becomes a district program to keep on top of that in perpetuity. Does that make sense from a cost standpoint when we compare to other types of projects? Now, the idea here is that we continue to do watershed projects and reduce that loading. So you should be lengthening the life of that because you're reducing the burial of that and you're capturing anything coming deeper in that sediment core up into that, right? So the idea is each time you do a treatment, it should get longer and longer until you can get it into equilibrium. So that's something that Terry and I are kind of looking through in terms of a cost standpoint, just trying to figure out maybe doing a presentation at Water Resources Conference or most places to kind of say, how does this geoengineering process, and we're going to look at lake and sediment, fit into a watershed district program like yourselves?
So I would suggest that this is the face of the watershed to the public. And so this has great value if this works as a rationale for continuing it. This is the face of the watershed to the rest
Making
of
us
the world.
cutting edge, is that what you're saying?
No,
Well,
it's just,
we've been doing it
it's
because
it's an important component. I mean, if you can't demonstrate what you're doing and not have it be part of a research paper, this is it.
when Peter Sorensen was working with us, I mean, that was a really good study. It had a lot of value because a lot of people didn't,
That's why it was brought.
because they did all that tagging and all that research on how the fish move around and all that.
Yeah.
So, I mean, we've been doing important stuff for a number of years.
Yes.
So that's another task order that we could put in. Again, Josh would do the coring, we would just do the data analysis if we record Riley to kind of see what the next steps are. So I just putting that out there. So if you see that come across, we're talking to Terry about doing that.
So is that something we have to get in front of somebody like PCA or something? I mean, if maintenance, if there's something we can do to keep a balance, is supposed to have to react to something all the time. Is that
Well, and that's
better?
what this would do. It'd
Yeah.
be, we would be staying at it. We'd be.
You'll hear people call it a Band-Aid approach,
Yeah.
right? You're just putting a Band-Aid on it, but that's not really, so is a pond that you put in the watershed, because it's capturing phosphorus from the source. Anything that's not a source reduction could be considered a Band-Aid. What we're demonstrating here is it's an effective tool in the toolbox for the long term to keep your water bodies in good water quality and maintain that.
And remember, there are lake watersheds where there are very limited opportunity to do things in the watershed. So then you have to look in lake, when you look at like the Mitchell Lake watershed, there isn't, we didn't come up with a whole lot of opportunities to something to do in there, so.
Right.
And I think
Yeah, we could take,
Just say, we have about
yeah,
8
5
minutes
minutes to
before
do.
our meeting. I would like to leave some time. Is there any urgent questions that we need to ask during this meeting yet? I mean, we got a couple minutes, but I'd like to
Yeah,
have some
my
time.
thought is I'll work with Joe, put together those task orders we've talked about. We can decide at that time if you want to move forward with those task orders or if
Go
not.
for it. So
so.
you don't need a motion from any,
No.
I mean, at the meeting, obviously.
Yep, we'll just put together task
Yep.
orders to be considered at April meeting or May meeting.
So just one other comment on this. I think, Fred, I think you mentioned it early on in your presentation here, but there's no one thing that we do that fixes anything. We live in a world that everything is always changing. So the question is, is this part of what we have to do now? And I think that's the question in front of us. We're saying that maybe this is something we have to continue doing because it requires attention over X number of years, and it's part of what we do as a watershed. Not just fixing it when it's out of control, but continuing to keep it at a level that we think is appropriate. So it becomes part of what we do.
I always liken it to blood pressure medicine. It's chemistry, you change it, but you have to continually take blood pressure medicine to maintain that. There are certain things that you might have to do. You're a pharmacist for lakes, essentially, is what I'm saying. But there are certain things you might have to do to modify that chemistry to maintain that water quality over time.
See,
Hopefully, we can get to an equilibrium where we don't have to do that anymore. That's kind of the holy grail of natural resources management at this point.
Well, that's what we're hoping. An ecosystem approach will help.
That's right. All those things start to go down that path towards that.
Watershed premises.
Okay, thank you. I believe we'd
All right.
like to
Adjourn?
adjourn.
Okay.
Do I
Continue to.
need a
It's all good.
motion?
You just say
or-
we're
I just say adjourn,
I forgot your name.
not a meeting.
Yeah.